Okay, so now we will talk about Archimedes Principle. Okay, Archimedes Principle states that a body immersed wholly or partially in fluid is buoyed up by a force equals to the weight of fluid it displaces. Okay, so yeah, let's straight away jump to some questions here. A block of a material 8 cm long by 4 cm wide by 5 cm high floats in a fluid of density of 900 kilogram per meter cube with 1/5 of the block submerged in the fluid. Please find the buoyant force on the block. Okay, so you know that the buoyant force is equal to the weight of the fluid it displaces. Okay, so buoyant force is equal to the weight of the fluid it displaces. Okay, so yeah, actually it should be like this. The weight of the fluid, right, is equal to the mass of the fluid times g, but then mass equal to density times volume. Okay, and then the volume of fluid that you displace successfully is just 1/5 of the total volume only. Okay, and therefore your buoyant force is 0.28 Newton. Okay, and then please find the density of the material. Okay, now you only know the density of the fluid, but then you do not know the density of the material yet. Okay, so when it stays afloat, okay, when it floats in the fluid, you know that this is a case of forces in equilibrium. So you say that the upward force is equal to the downward force, and then the upward force is what? Is your buoyant force. Okay, and then the downward force is the weight of the material. Okay, the weight of the block itself. Okay, so what do? You cancel g. Okay, you cancel out g here, and then yeah, volume of the fluid that you displace is this, and then the volume of the material is this. Okay, so finally you can say that the density of the material is 180 kilogram per meter cube. Okay, so now a piece of plastic. Okay, this is a piece of plastic. Okay, with a density of 706 kilogram per meter cube is tied with a string to the bottom of a water-filled flask. The plastic is completely immersed and has a volume of 8 times 10 power negative 6 meter cube. What is the tension and strain, please? Okay, yeah, you know that it stays afloat, right? Okay, it is floating. Okay, so that you know this is also a case of forces equilibrium. Okay, so yeah, downward force is equal to the upward force, and then the downward force is the tension in the string plus the weight of the plastic itself. Okay, and then the upward force is the weight of the fluid that you displace. Okay, and then yeah, the weight of the fluid you displace is this one. Okay, okay, the mass of the water times the gravitational acceleration. Okay, and then yeah, so you substitute everything, then you get this. Actually, while you are watching this video, now you are a person, right? And then you are on the earth, and then you know that actually you are surrounded by some air molecules, and then actually I will tell you that the atmosphere is also like a fluid. So actually you also feel a buoyant force right now just because you are in the atmosphere. Okay, just because you are surrounded by air molecules. However, the density of the air is something like 1.225 kilogram per meter cube. Okay, so the density of the water is what? Is 1000, you know. So you know that the density of the air is really so small, and then the buoyant force you feel right now is what? Is rho a g times your volume. Okay, your body's volume. So you know that the buoyant force that we feel when we are in the air is really very tiny, so it's like you don't feel it at all. However, if you go to swim, then the buoyant force you feel is rho water g times your volume, okay, so that you can feel a greater buoyant force when you go swimming. Okay, yeah. So in the next video, we will talk about the continuity of fluid flow and Bernoulli's equation. Thank you.